All right, guys, this is going to be a short lesson on circumference diameter ratio, and we're going to review again area of circles. Since this is a chapter of circles, the book just wants to tie that in again. Okay, so circumference diameter ratio. Circumference is going to be C, and D is going to represent diameter. So whenever we're going to recall that formula, okay, we're going to use pi, which is a number. A lot of people tend to forget that pi is a number. Pi is a long number, 3.14 and so on. And so C is always going to be equal to pi times the diameter. Now, remember the diameter is equal to 2 radii. So R is representing the radius. And so the other way to write the formula out is 2 pi R. Okay, and so if you look at this diagram over here, remember pi is roughly 3.14, right? So if the circumference, which is the length around the circle, is 3.14 times the diameter, you can see over here in green, here's one diameter. Okay, again, you're taking the length of the diameter. Here's the second diameter. Here's the third diameter, and then there's that one little piece left right there that is about 0.142 of a diameter. And that's how the ratio works out. There's 3.14 diameters around the length of a circle, which is called circumference. Okay, and then one last thing we'll do a little bit of is the area of a circle, which is pi r squared. All right, let's do a few examples right here. I wanted to review this one because on the assignment you have some problem examples where you have to find the exact circumference and the exact area. All that means right there, guys, is you want your answer in terms of pi. So you want to write that down in terms of pi, okay? Or if you have a radical or square root, you want to make sure that you leave it in radical form, okay? When you start putting decimals, then it's not exact anymore. It's a estimate. So let's find the circumference first. Circumference is pi times diameter. I don't see a diameter, but if you draw in a diameter right there, then we can perhaps solve for it. So it does say ABCD is a square, so this is 18 over here. And then this diameter right here is the part of a right triangle. This right triangle is a special right triangle. It's a 45, 45, 90. So if you recall that, if the legs are 18, then this whole diameter is 18 radical 2. And if you forgot that, you could do 18 squared plus 18 squared and solve for c squared, or c, using Pythagorean theorem. And if you reduce that, it will reduce to 18 radical 2. So the diameter is 18 radical 2. So when I plug that into my formula, pi times 18 radical 2, you really don't want to do anything else beyond that because we have to leave it exact. So you'll want to punch that into your calculator and get a decimal, but then we're giving an estimate. So here's how you write your final answer. You write 18 pi radical 2. And that is the exact circumference here. And this is actually feet. So let's go ahead and put our little feet right there. 18 pi radical 2 feet is the circumference. Now, if you wanted to give an estimate, then you would just punch that into the calculator right there. Okay, but it did ask for the exact. Okay, let's try that with area now. Okay, so for area, we have pi r squared. So what is r? If the diameter is 18 radical 2, then that means r is 9 radical 2. So we're going to plug in pi 9 radical 2 squared. Think of 9 radical 2 squared the same thing as 9 radical 2 times 9 radical 2. Okay, which 9 times 9 is 81. Radical 2 times radical 2 is just 2. And so 2 times 81 is 162. And then don't forget you have pi out in front. So 162 pi, and this is square feet, is our answer for the area, the exact answer that is, for the area of that full circle. Okay? All right, let's try one more problem. If the diameter of the Earth is 8,000 miles, find the average speed. Okay, so I want to underline that. This is what we're finding. The average speed in miles per hour that Phileas Fogg needs to circumnavigate the Earth about the equator in 80 days. Okay, so remember the equator goes around like this and back around. So that's the biggest circle on the Earth. And so if the diameter is 8,000 miles, we're going to do circumference equals pi times diameter. So it's 8,000, which is the diameter, times pi, and this is going to be miles. So this is the distance around the Earth about the equator. Now, that's not what they asked for. They want us to know, they want us to find the speed in miles per hour. So I have to divide this. Remember, in order to make it miles per hour, you need to divide by the number of hours needed. Well, we're going in 80 days, but I need that to be in hours. So I'm going to take 80 and times that by 24 because there's 24 hours in a day. So let me get my calculator. 80 times 24 is 1,920 hours. So I want to take my 8,000 pi and divide that by 1,920 hours. Okay, because remember this is miles on top, hours on the bottom. And so now I'm just going to punch that into my calculator. And let's see what we get. So 8,000 times pi, I like using pi in the calculator, equals roughly 25,132.74. Then I'm going to just divide that by 1920. So 25,132.74122. Now I'm going to divide that by 1,920. I mean, just 1 0. Sorry, ignore that last 0. So that's going to take about 13.09 miles per hour to get around the world in 80 days. So he has to go 13.09. Now, if you don't remember who Phileas Fogg is, he's in a hot air balloon. Can't draw a hot air balloon, but this is a hot air balloon that he's in, and he's going about the Earth in a hot air balloon. So 80 days, hot air balloon, 13.09, about 13 miles per hour is what he'll have to go. And that's it. Short lesson.